All right, we are starting Unit 8, and we'll be working in circles. Okay, this lesson's titled Learning Targets, Angles, and Arcs in Circles. All right, so let's start off by figuring out what a circle is. A circle is a set of points that are equidistant from a given point called the center. Our equidistant means same distance. So a circle is made up of all these little points. So imagine all these infinite number of points, just all these little dots going around, and they're all the same distance from the center. So if I measured from G and I measure a straight line to any one of these points, it would be the same. Okay, whether it be 4 inches, 2 centimeters, whatever. All right, so those points that are all the same distance away from the center form a circle. All right, the point in the middle that they're equal distance from is called the center point, which is right here. So once again, a circle is named by its center point. So this would be circle G. Okay, and we record it this way. Circle, because it has a center, G. All right, so that's how it is named. All right, there are 3 special segments in a circle, and you may be familiar with some of these names. You may have seen before, maybe not. Okay, so 3 different segments we're going to talk about: a chord, a diameter, and a radius. All right, so a chord, and it's spelled or pronounced chord, is a segment with endpoints on the circle. Both of the endpoints are on the circle. Okay, so taking a look, let's look at it. AB is an example of a chord. AB, or BA, however you want to name it. There's another one, DC, is also a chord because both endpoints are on the circle itself. Is EF a chord? No, it is not. Okay, well, F is on the circle, E is not. It's in the middle. So in order to be a chord, both endpoints have to be on a part of the circle. Some chords will be bigger than others depending on where on the circle their endpoints are. All right, the diameter is a chord that goes through the center of a circle. So not only are the 2 endpoints on the circle, but it has to cross through the center. So looking at it, my diameter in this example is DC. It goes through the center. It measures the circle at its widest point, at its, fattest point. Okay, and then the last one is the radius. And the radius, scroll down here, is a segment with 1 endpoint on the center and 1 endpoint on the circle. Okay, so it has to connect from center to circle. It can't connect, it cannot be like from here to here. Okay, while one end is on the circle, the other's not in the center. So in order to be the radius, it has to connect from the center to the circle. So our only radius that we see in this diagram is EF. There are more. Actually, just kidding, there are more. We also have ED. Sorry. It's not the entire thing, but half of it, ED. Okay, and the other one would be CE, okay, because it also connects the other side from the middle to the end. All right, so CE. All right, so the length of the diameter is twice that of the radius. So once again, the length of the diameter is twice that of the radius. So the diameter is bigger than the radius. We also could say that the radius is half of the diameter. Okay, so depending on which way you're thinking about it, the radius is half of the diameter. So for an example, let's go ahead and fill in the missing blanks. If I tell you the diameter is 10, we know that that is twice as long as the radius, or the radius is half of that. So what's half of 10? It's 5. All right, in the second example, I give you the radius. Once again, the diameter is twice as long as the radius. So if the radius is 6, the diameter has to be bigger, so I'm going to double that. So if I'm going this way, I'm dividing by 2. If I'm going this way, I'm multiplying by 2. So it's 12. All right, if my diameter is 8, I want to find the radius that's smaller, so I have to divide, so I get 4. And if my radius is 3.5, I'm going this way, I'm getting bigger, so I'm multiplying, so it is 7. Okay, so we can look at the relationships between the lengths of the diameters and the radius. How is that going to help us? Well, and you've seen these before, but circumference. Circumference of a circle is a distance around the circle. Okay, if you were to think of a soup can, right, if you look at the top of it, or if you look at the label, it makes a circle. Granted, the whole shape is a cylinder, but if you just look at the top, it's a circle. All right, it goes all the way around. If we were to take off that label and unfold it, it's going to make a rectangle. Okay, so circumference is a distance around the outside, as you can see by this red dotted line. So there's one formula, but two different ways to write it. C equals pi d. C stands for your circumference. Pi is that magical mathematical number. D is your diameter. Okay, and the other way we can write it is 2 pi r, radius. Why? Well, because the radius is half of the diameter. So if I say, okay, well, I'm given that diameter, I can just multiply it by pi to get my circumference. Or if I'm given the radius, I'm going to first multiply by 2, because then I have the diameter, and then multiply it by pi. And once important to know, formulas will be on the SOL formula sheet, so you don't have to memorize them, but you do need to know how to use them. All right, the question asks us, what type of units does circumference have? How do we measure it? Is it degrees? No. It's measured in things like feet, inch, meter, centimeter, okay? A yard, you get the point. It's not a degrees measurement. It's a distance measurement. Okay, on to the next page. Okay, I want you to try this on your own. It says find the missing measurements. If I give you the radius, please find me the diameter and then the circumference. And then if I give you the diameter, find the radius and the circumference also. Leave your answers in terms of pi, meaning don't actually multiply out the pi. Keep it like a variable. So go ahead, pause the video, give it a shot, and then when you're ready, press play and I'll talk through it. Okay, I'm pausing. Okay, let's take a look at the first example. So if the radius is 3 inches, the diameter is twice that. So 3 times 2 is 6. Notice I also put my units. All right, so to find the circumference, it is pi times diameter. 6 times pi, my diameter is 6. Now here's what I mean by leave it in terms of pi. Okay, and you only do this if you're told to. If the directions say round to nearest, I don't know, 10th, 100th, whatever, you got to multiply it out, and you can do that on your calculator. All right, so 6 times pi. I didn't actually do 6 times 3.141529, which is the beginning part of pi. All right, I left it there as pi to kind of keep it neater. All right, in example number 2, I was given the diameter, so I could go right to my circumference. It's the diameter times pi, so it's 7 pi meters. All right, and then to find the radius, I divided it by 2. All right, so vocab. Let's go on with what is new that we're going to learn. We're going to talk about central angles and arc length, okay, or I'm sorry, arc measures. So a central angle, think about central being center, is an angle that is in the middle of the circle. It's an angle with the center of a circle at its vertex, meaning if you think of your angle and its crooked elbow, this the vertex of that angle, this part right here, okay, is the at the center of the circle. And what's important to notice is the sum of central angles is 360 degrees. So all of these all these angles in here, if I were to draw more, no matter what, at the end of the day, they're going to add up to 360 degrees. Think of yourself turning in a circle. When you make one complete turn, it's one complete circle, it's 360 degrees. Okay, so it's already highlighted for us. Arc of a circle. The arc of a circle is a section of the outside part of the circle, part of that circle. Ow, sorry, I ran into something. That circumference area. Okay, so taking a look up here, we have arc AB is highlighted. Okay, it's the arc from A to B. And what we're going to learn today is how to find the measure of that. All right, so to write the notation, we write M, and we put the AB with an arc over it, like that. So it's saying the measure of arc AB. Okay, so we learned central angle, which is an angle that has the vertex is the center of the circle, and then the arc is part of the outside of the circle, part of that circumference. So let's now combine those two facts together. Actually, sorry, one second. So I can't actually scroll down on the board, so I have to keep walking back to the computer, which is why I forget there's more on each page. Okay, so intercepted arc, let's combine it together. An intercepted arc is an arc that's created by an angle. So we're taking that concept of the central angle and the arc and putting it together. So arc AB is not just an arc that I'm choosing, it's created by this ACB angle. sorry, that's an angle ACB, or we could call it angle C, naming it by its center. Okay, but angle C, when I draw that angle ACB or angle C, however you want to name it, it creates on the outside this arc AB. Kind of looks like a pizza pie, the crust. Okay, that is an intercepted angle, an intercepted arc, an arc created by the angle. So, a central angle equals the degree measure of its intercepted arc. Meaning, if I tell you that this angle right here is 110 degrees, that is the same measure for the arc. Okay, so arcs, when I'm talking measure of arc, I'm talking degrees. So, be careful here. Circumference, the whole outside measures in feet, inches, meters, whatever. If I'm talking the measure of an arc, I'm talking degrees. Got to keep those separate, okay? So the outside arc, the intercepted arc, is the same as the angle, the central angle, okay? It can't be any angle, okay? It has to have a center on the vertex, or the vertex on the center. So once again, with that being said, the measure of arc AB is 110. Okay. So there's a couple different arcs that we're going to talk about. The minor arc, the major arc, and a semicircle. Minor and major, think about what those words mean. Minor, small, major, big. Think minor leagues, major leagues. Minor being, the lower level in baseball, majors being the higher level. So a minor arc is written with only 2 letters. Keep that in mind. And it's always less than 180. Never equal to, less than. So it could be 179, it could be 1 degree. Okay, but it's always less than 180, which is half of the circle. So if I take a look at my example, okay, looking at this circle right here, AB is an example of a minor arc. All right, it does not go more than halfway through the circle and it only names 2 points. That's one example. I could also say BC. Okay, I could also say CD, which is at the bottom, or AD. Okay, so those are all examples of minor arcs. A major arc, major meaning bigger. Okay, it's written with letters of the 2 end points and another point on the arc. It's always more than 180 degrees, meaning it's more than half of the circle. Now, going back up to this, it's always written with letters of the 2 end points and another point. Super important, and we'll talk about why. Okay, so one example would be ABD. I'm going to scroll up. I want you to think for a second, why is it super duper important that I also said it B? Why could I not just call this AD? Why could I not just call this AD? Here's why. So the major arc ABD, I could have said ACD because that's another point in the middle. I only need to name 1 point in the middle. But if I just said it's arc AD, okay, if I just named it with 2 points, that could also be referring, and I'm going to do it in blue, to this minor arc over here. Okay, because it doesn't specify direction. So if I don't use one of the middle points in between, I don't know which way I'm going. So you have to use ABD or ACD to specify which direction to go, and that is a major arc. It's more than half the circle. It's more than 180 degrees. Okay, and the last one is a semicircle. It's written with the letters of 2 endpoints and another point on the arc, and it's always half the circle. It's 180. So I have so many different ones. I could do ABC. I could do ADC. I could do BCD. Okay, DAB, whatever. Anyone that's half of the circle. And I know that's half because this is my diameter right here from D to B, okay, which cuts in half, goes through the center. So I know that if I have an arc hits the 2 points of a diameter, I'm good to go. All right, before we move on, think about this. A semicircle can also be named with only 2 letters. Why? Okay, so a minor we can name with 2. A semi we can name with 2, but not a major. Here's why. It doesn't matter which direction you're going. Okay, if I want to look at arc DB, I could go DAB or I could go DCB. Okay, it's arc DB. All right, let's go on to the next page. All right, so central angle equals a degree measure of the arc. We talked about that. So now we're going to use that information to help us find missing arc measures. Okay, so we need to find the measure of arc AD and the measure of arc ABE, or I'm sorry, ADE. Now, let's take what we know. Remember, all the central angles add up to 360 degrees, which means all the arcs add up to 360 degrees as well. Okay, if I'm finding arc AD, let me draw it first, highlight it. I have no information, but I do, because take a look at this. If this part right here is 90, and this makes it 180, this must be 90 also. Okay, that is a 90-degree angle. I could cut my circle into 4 90-degree angles. So if this is 90, the arc is 90. Okay, so I've got part of it. Now, I need to find DE. Well, this one right here is also 90. I already know that this is 70, so DE is going to be 90 minus 70, which is 20. Okay, so let me do it in green, from here to here is 20. From here to here is 90. So to find arc AD, I add them together and I get 110 degrees, which also tells me that angle DBA is 110 degrees. All right, now if I want to find the measure of arc ADE, same thing, start by drawing it so you know we are looking ADE, going in the correct order, not to the right. I have to go all the way around A, I have to hit D next before I get to E. So there's two ways we could approach this. Because it's a major arc, it's going to be more than 180. So when I look at it, I already know this is 90 degrees. So what I could do is do the whole thing minus 90. I could do 360 minus 90. Because I have pretty much the whole entire circle covered except for that part. So it's 270 degrees. You also could have tackled it by saying, okay, well, I'm going to add it together. This is 180 because it's half of a circle. I know this is 70. I already figured out this is 20, and then add them up and get the 270 that way. Either tactic will work. Okay, I'm going to pause the video, and I want you to try the example on your own. Give it a shot. Find those arc lengths. Go ahead and pause. Okay, check out your answers. The measure of arc OK is 90. The measure of arc LM is 67. And the measure of arc JKO is 316. Let's take a look at why. Let's start with OK. Okay. All right, so from here to here, what do we know so far? We know this guy is 67 up here. We know this guy's 46. Well, I also know that this one is 46. Why? Because JPK and NPM are what? Vertical angles. So since this arc is 46, this is 46, meaning this is 46, meaning this is 46, okay? You don't need to label all that, but I just want to explain where I'm getting my numbers from. So that is 46. All right, so how do I find JO? Well, I know that these three together, K from KON, okay, so KON, which I will highlight in red, that whole thing's a semicircle, so it's 180, okay? I already know this one's 90. Right, because it's told to me. So what I'm going to do is add up the 46 and the 90, and I'm going to get 136, and I'm going to subtract it from 180. And I end up with 47. So that means that this leftover piece is 47. Oop, did I do my addition wrong? 46, 136, subtract. I'm sorry, that's not 47. That's 43. Just kidding. Guys, my brain is in La La Land. 44. 180 minus 136 is 44. Oof. Okay, so when I add those two together, the 44 and the 46, I get 90. So that's how I got okay. All right, let's take a look at LM. All right, LM. Over here, need to find that arc length. I'm going to use the same tactic. I have a semicircle here. I already know two of the pieces. I know 46 and 67. So when I add those two together, I get 113. And when I subtract that from 180, I get 67. So that means that LM is 67. Okay. And then JKO, let me erase some things so I can tell where I'm looking. JKO goes from J up to K all the way through to, oh, it's everything except this piece. Well, we already figured out that piece that was, now of course I've gone and erased it. We said that that one was, shoot, 44. So in order to find everything else, I'm going to do 360 minus 44, and I get 316. That's how I got it. Okay, last page. Same thing, but now we're going to apply variables to it. Okay, so our task is to find the measure of arc RTS and QTR. Same exact thing, except we have to set up equations. So first thing we need to do, guys, is we need to find the value of x. And if you notice, look for semicircles. I have one right here. Here's a semicircle. A semicircle is 180 degrees. So I can write an equation and add up 3x, oh, that's a minus, 3x minus 20 plus 6x minus 15 plus 5x plus 5 and equal it to 180, okay, because they're all on a semicircle. So to solve this equation, 3x plus 6x is 9x, plus 5x is 14x. Negative 20 minus 15 is negative 35, plus 5 is negative 30, equals 180. Now I add 30 to both sides, I get 210. And then I divide, and I get that my x value is 15. Okay, so that doesn't give me an arc length, it gives me an x, and now I can just plug things back in what I'm looking for. Okay, so first I'm going to look for RTS, which is off my screen, but that's up there. So RTS, I'm going to highlight in, angle RTS, yep, right here. So I'm going to use this, 3x minus 20. So for RTS, it's 3 times 15 minus 20. 3 times 15 is 45, minus 20 is 25. So RTS itself is 25 degrees. And then if I was asked to find the measure of arc RS, it's also 25 because RTS is the central angle. Okay, and then the measure of angle QTR. QTR is right here. Okay, I have no information in it, but hello, I've got a vertical angle. So those two angles are going to be congruent. So I can just plug it into this guy. So 5x plus 15, or plus 5. So I have 5 times 15 plus 5. 5 times 15 is 75 plus 5 is 80 degrees. So the measure of angle QTR is 80 degrees. And then if I were asked to find the measure of arc QR, it's also 80 degrees. All right, we are done for today.